Today we are in beautiful Santana Row, California, where people drive fancy cars. You know what that makes me think of? Object-oriented programming in Python.
A class in object-oriented programming is very similar to a blueprint in real life. Imagine the process of building a car. Your engineers will start with some drawings, add information to it, up until the point where that completed blueprint can be passed to your assembly line and your factory workers, for example, can follow it and build a physical car. Let's go over a simplified example. For instance, your engineers could define that the fuel consumption of this car is 30 miles per gallon, its top speed is 150 miles per hour, and this car has headlights. These attributes apply to every car that is built from this blueprint. So no matter how many cars you build from this blueprint, they all will have headlights, they all will have the same fuel consumption and same top speed. We call them class attributes. We also have attributes that apply to each individual car. For example, what color did the customer order the car? Or what interior material did they want the car to have? Fabric seat or leather seat, for example. We call these instance attributes, which means they are specific to that individual car. So what does this look like in Python? We use the keyword class followed by the name that we want, and now we can define the attributes that we talked about. So we have top speed, MPG, and headlights. And headlights for now can only have the values of off or on. I'll also define an attribute called location, which tracks where the car is in a one-dimensional space, which means the car can only go forwards or backwards. I'll come back to this later in the video. We also talked about attributes for each individual car, or instance attributes. We use something called a constructor method to define that. In Python, the keyword for that is init with double underscores before and after it. This can be called constructor method, instantiation method, or initialization method. And it is called automatically when we try to create an instance from the class. We usually pass the keyword self followed by the other parameters that we need to the constructor method. Self is an agreed upon keyword. You could use any other keyword that you like, but what it means is that instance of the car needs to have that value. So self color equals color assigns that color that we pass to only that individual instance of the car. In addition to attributes, we can also define the functionalities of this car. For example, we can drive the car, or we can switch the headlights on or off. We call these instance methods, which means we can apply these operations on each individual car. Instance methods are the same as any other Python method outside of a class, except that we pass the self keyword to them so we can apply the operations to that instance attributes. For example, for the drive functionality, when we pass distance to that, we can update the location of that individual car by the distance that it drove. Or for the case of switching headlights to on or off, we will update the headlights for only that single car. Now what happens if I try to print out a couple of these class attributes? So for MPG and headlights, I expect to see 30 and off. That looks good. What happens if I try to print out an instance attribute like color? The editor gives me this highlight which is saying this attribute doesn't exist on the car class, and if I try to print it out, I get a nice error telling me what I'm doing does not make sense, which is what we expect. Color does not belong to the blueprint, it belongs to an instance of a car, and we have not built a car yet. So let's build one. The way to instantiate a class, or build a car in this case, is to just call the class and pass the parameters. So if I just call car and pass, for example, red and leather, I will build a red car with leather interior. Similarly, I can define another car. Let's make this one blue with fabric interior. Remember how earlier we were not able to print out the color from the class? Now let's try to access the color attribute for these instances of the car. So if I print out car1 color and car2 color, I get red and blue as expected. As a side note, you can also pass default arguments to the constructor method similar to any other Python methods. So in this case, I see an error on car2 because I am not passing the second argument, but if I define a default of fabric for interior, then second car should have a fabric interior. So if I print out the interior for both cars, I should see leather and fabric.
This video is brought to you by no one. Absolutely no one. I am waiting for a call from BMW though.
Let's talk about the drive method. It is returning the current location of the car every time we drive a certain amount of miles. So if I drive 10 miles, then I should be able to print 10. If I drive another 10 miles after that, then the next line should print 20. Now, what happens if I directly update the location of the car between these two statements? So if I set car1 location to 2000, now I suddenly get 2010 at the end, even though I didn't drive that much. I only drove 20 miles. To safeguard ourselves from a scenario like that, Python has something called a private attribute. So we can achieve that by adding 2 underscores before the attribute name. So if I add 2 underscores before the location, now this attribute is treated as private, which means only from within the class I can access this and update it. Now if I print the same statements, I get 20 at the end, which is what I wanted. And you may be wondering, well, you're not updating the correct attribute. So even if I add the underscore to location outside and update it, again, I will get 20 at the end because that internal attribute is not getting updated. So how's Python really doing that? To understand this, let's try to print out the underscore location outside of the class. Even though the editor will give us an error saying this is an unresolved attribute, we can still print it out because we have set that value to the car object. So as you see, it is 2000. So how is it that when we print out the second drive, we are not seeing this 2000 value added up? The reason behind it is Python renames this value behind the scenes, so you are a lot less likely to unintentionally update it. And it renames it to the underscore name of the class, double underscore name of the attribute. So if I really want to shoot myself in the foot and update that outside of the class, I still can by writing the full name of the private variable. And as you see, if I print this out, again, I get 2010, which is as if the car teleported to that location. Okay, let's clear all of that out. The last item I want to talk about is private methods. Similar to private attributes, if we add 2 underscores before the name, Python considers that private. For example, for this commentate method, I want to announce how much each car drove when they actually drive. So I will call this method from within the drive method, which is a public method. So any method that doesn't have the double underscores can be called from outside the class directly, which means that's a public method. And any method that has the 2 double underscores are private, which means that a method from inside the class can call it, but not directly from outside. So let's try this out. If I write car1 drive 10 and car2 drive 50, then I expect to see red car drove 10 miles and blue car drove 50 miles. So what happens if I try to directly call the commentate method? So since I'm calling a private method, I expect to see a warning from the editor. So it's saying this attribute is unresolved. And if I try to print this out, I get a nice error telling me the same thing basically. Similar to private attributes, if we are really determined to call this private method from outside the class, we can use the underscore name of the class followed by the name. Still, we get the warning because the editor is telling us you're not supposed to access this, but we can do it and we can print it out. So in this case, we are announcing that the car drove while the car did not drive. The concept that we hide or restrict the access to private methods or private attributes, or in general when we hide the implementation of the class so the consumer of that class from outside can only interact with the public methods or what we expose from it, is called encapsulation. We are basically encapsulating some internals to simplify how a person or a consumer can interact with what we built. For example, in the case of a car, as the driver of the car, you only need to know how to drive and how to push the gas pedal, how to turn on and off the headlights and things like that. You don't need to necessarily know what's happening in the engine or how transmission works. These things happen behind the scenes whether you know about them or not. This is basically the idea of encapsulation in object-oriented programming. An example of it in what we did here is the drive method, where we are updating the location and calling the commentate method without exposing these two to the outside world. Let's do a quick recap of this first section. We learned about class and class attributes. We learned about constructor and instance attributes. We learned about private and public methods, and also how to create an instance of a class. Lastly, we also learned about the concept of encapsulation in object-oriented programming.
In the next video, we'll talk about inheritance and some more advanced topics in object-oriented programming. See you soon.